Now is actually a really exciting time to be a radio astronomer. There is a plan by an international consortium to build a huge radio telescope, much bigger than any existing instrument. This telescope, known as the Square Kilometre Array, will be very large and very sensitive, which we hope will revolutionise our view of the universe. But how do we build a telescope for new discoveries when we can't even be sure what those great discoveries are? To find out, I spoke to Professor Peter Hall, who's been very closely involved in the design of the Square Kilometre Array. So Peter, what area of radio astronomy interests you?
Well, John, I have many interests, but at the moment my big one is radio astronomy engineering and also time domain astronomy, the science of the snap, crackle and pop events from the radio universe.
You're deeply involved in this project. It's a very large project. So tell us a little bit about the SKA.
The SKA really came about in the late 80s and early 90s when astronomers decided that they really did need to have a radio telescope that allowed them to look back to the very early days of the universe, to the emergence of the first stars, galaxies and other ordered structures from the pristine universe. And when they did the calculation of what sort of telescope would be required in order to do that, at about the 1 gigahertz frequencies, they found that indeed the collecting area needed was about a kilometre square, a million square metres, 1 square kilometre. And so that's how the telescope got its name.
So it's clear that there's a lot of discoveries out there waiting to be made in radio astronomy. So what are the main goals for this upcoming instrument?
The early universe really remains top of the list for the SKA, and in particular a time in the history of the universe known as the epoch of reionisation, which you may describe in your course. This is the holy grail, if you like, the ability to image the signatures of the epoch of reionisation, to watch the emergence of those first structures. But as well as that, the SKA has a number of other big goals, and in the early part of the telescope, one of them is to look at pulsars across the universe, discover many more pulsars, do accurate timing measurements on many more pulsars, and by those means to identify, for example, gravitational waves in the universe.
Yeah, we certainly will be talking about the epoch of reionisation later in the course. We've also been talking about some of the great discoveries in astronomy, and particularly in radio astronomy. We've looked at Jansky's discoveries, and we've also looked at the discovery of pulsars. And one of the themes that we've noticed is that for all of these great discoveries, the person who made that discovery wasn't actually setting out to make it. It was a serendipitous discovery. So how do we go about building this brand new instrument which is going to be so much bigger than any existing radio telescope when we don't actually know perhaps what its big discovery will be?
That's a very good question. And I think you've got two of the main elements of discovery there, smart people and serendipity. But the third big one is actually technology advance. And the people that you mentioned there all were working with brand new technology, with capabilities that hadn't been around before. So the SKA is, if you like, the third part of that recipe for discovery in radio astronomy. It's the big instrument with orders of magnitude increase in capability relative to existing instruments. And although it's a hard line to sell to funding agencies who pay for telescopes, historically we can be almost certain that the combination of the right people, the opportunity, the serendipity and the transformational technology will produce the shattering new discovery science from the telescope.
So we have plans to basically use as new technology as possible, open up new areas of radio astronomy, and then hopefully the really big discoveries are almost inevitable. What are the plans for the next decade?
The telescope, in fact, like all good telescopes, is being planned with technology that doesn't yet exist, at least at the price that we will have to be able to afford it. So it's more than a cutting edge. It's almost a post-bleeding edge technology design game. And what we're going to do in the next decade is to build what we call phase one of the telescope, which is roughly 10% of the sensitivity of the full SKA, and that will be sufficient, we believe, to give us these new insights into the early universe and the pulsar population and by extension new results in general relativity and related cosmology.
Even with just 10% of the final instrument, we can already go well beyond what current instruments are capable of.
That's correct, yes. The capability of the SKA Phase 1 will be considerably in advance of the telescopes we have on the planet at the moment.
Professor Peter Hall, it's been a really interesting experience speaking to you, and it sounds like a phenomenally exciting environment to be working in. Thank you very much.
Thank you, John.
So we do have a series of key science projects, discoveries that we know we want to make with the Square Kilometre Array. In addition, by focusing on survey science, we maximise our possibility of discovering the unexpected. We can also look at what's been done before, and perhaps more interestingly, what hasn't, to help inform us what might be fruitful areas of study.